Hey everyone! The end of 2024 is slowly approaching, so I thought it would be good to add at least one more post-processing effect before diving into something more complex next year. This time, it's again about layering, with each layer shifted differently using a noise texture and rotation. With a bit of imagination, the result can resemble a painting where the colors have blurred and blended together slightly. Let's take a look at how this algorithm works. This time, I will apply a shader to an image, so instead of the usual color act, I will create a scene into which I'll drag the mentioned image, which will create a sprite 2D node, like this. Right click, create new scene, and let's call it painting. Okay. And the picture we have here, let's drag it to the scene. So sprite 2D node was automatically created, and in the inspector I'll do the usual stuff. Offset centered, disable, and transform position reset to 0, 0. Okay, and let's not forget about the material, which is down here. Material, new shader material, click, new shader, and the shader is painting GD shader of the type canvas item, and I'll put it to the shaders folder as usual, and create, and click to open it in the editor. Okay, and of course, as you know, we delete everything that isn't needed, so we are left with just a fragment function, deleting vertex and deleting light. Okay, I mentioned noise texture and layers, so we'll need uniform parameters of this type. For the layers, we'll use iterations, and as a third parameter, I'll add a shift, which will control the state of the entire effect so it can be managed later with scripts in our game. So let's do it. Okay, uniform sampler 2D, noise tags, and repeat, enable, of course. Why repeat enable? Once we set the texture, its dimensions will be fixed and may not match the dimensions of our background image, so we'll allow the texture to repeat horizontally and vertically. Let's continue uniform float iterations with a hint range, and let's start at 10 layers, and the range would be from 1 to, let's say, 50, and the step, of course, 1. Okay, and the third one, as I said, we would use some kind of shift. So uniform float shift at a hint range, and the initial shift is at 0. Range from 0 to 1, and let's make the step point 0, 1. Okay, and now the fragment function, which will implement where we implement the layer shifting and their composition into the final image. For this, we'll need to read values from the noise texture and incorporate them into the overall calculation. So let's write the basic algorithm. Let's delete the comment and start with the usual stuff. Back UV is UV, okay, and the initial color would be the black color, which we'll use as the accumulator to add layers one by one. Alright, and now reading from the noise texture. So float noise is the function texture applied on the noise texture. Noise text, okay, and UV coordinates. Alright, and we need a float value, but texture returns vector 4, so we'll just take the red component. We can use any kind of component here, red, green, blue, because the noise texture will be in grayscale, so all these components are equal. Alright, and now the iterations of the layers. For float I is from 0 to number of iterations, I++, Alright, so I'll define the basic offset as a unit vector pointing horizontally to the right, slightly increased by this coefficient in each iteration. And the coefficient, I'll write it right away. Vector 2 offset would be vector 2, 1, 0. This is the vector pointing to the right, and multiplied by a coefficient which depends on the current iteration index, 1 plus I times 0.005. Okay, so we don't overdo it. Multiplied by the shift value, and I think it would be still too much of a shift, so let's divide it by 10. Okay, and we need to add it to the color value. Color would be increased by the texture function applied on our image, the texture, and UV increased by the noise value and multiplied by the offset value. And again, we have our color is vector 3, but texture returns vector 4, so let's take RGB components only. Alright, this is the accumulation of layers, and now we need to normalize the result because it would be again too overexposed. Let's divide the final color by the number of iterations, and we can assign the result to the color variable, which is vector 4. So we use our vector 3 color and 1 for the alpha channel. Let's wait. Okay, of course we don't see any changes yet because we didn't apply any offset yet. So let's try adjusting the shift parameter in the inspector. It would be here in shader parameters, and I'll just drag this bar and we can see the image shifts to the left and blurs slightly. Let's get back. Which is because we haven't created a noise texture yet. This is empty. So each pixel is shifting in the same way. Let's fix it. Okay, so I will add a new noise texture 2D, click it, and now I want it to be seamless, and I want to add some kind of noise. There is just fast noise light. All right, and let's drag the shift again. Very well. This already looks more chaotic, but we are still shifting pixels in only one direction, as you can see when I change the shift parameter again, just to the left. Alright, so we'll solve this problem by changing the vector direction for each iteration, shifting the current layer accordingly. There are various ways to do this, but the simplest is probably a basic rotation. So I will add a new uniform parameter, rotation, and a rotate function that will return a matrix to rotate the vector by a given angle. Okay, here we go. Uniform float rotation, hint range, and the initial rotation 1. Alright, and it would be from 0 to, for example, 2 with the usual step 0.01. And now the function. Okay, let's put it here, and it would return a two-dimensional matrix, rotate, float A for angle, and now float SA is sine A, float CA is cosine A, and we return the matrix 2, which consists of two vectors 2, CASA, and the second one is negative SA and CA, and that's it. Alright, this is the standard formula for the two-dimensional rotation, and I think I used it already in some of the previous videos. Very well, and we'll improve our offset vector this way. Where is the offset? Here. So we need to multiply that by the rotate function. rotate I times rotation. Wait for it. That's much better. I think we are quite close to the final effect now. We can try changing the rotation parameter and observe its effect on the outcome. Where is it? Here. So we'll just move it to the right, to the left, or make it 0 to turn it off completely. Great. Maybe we could experiment a bit more with the noise texture, because the default algorithm might not be the best fit for our effect. Let's try this. I'll click it again and click the fast noise light, and we can see it's simplex smooth, but maybe the cellular would be a better one, especially if we increase the frequency like this. Okay. Alright, maybe it's not a huge change, but I like it. I'll leave further experiments up to you, and let's improve the effect a bit more. The values obtained from the noise texture are in the range of 0 to 1 and are more or less evenly distributed, which affects the sharpness of the resulting blur. We can influence this with another parameter, which we'll then use in the power function, like this. Uniform float sharpness, again with a hint range, and the initial value let's set to 2, and the range would be this time from 1 to 10, and again the step point 0.01. Okay, and the corresponding change in the code where we define the noise, we will wrap it to the power function, pow, and the argument would be our sharpness. Okay, very well. Now we can fine-tune the final effect a bit more. Notice that with a higher number of iterations we achieve a much blurrier effect. So let's just change, shift, no, let's keep shift as it was and move the sharpness. Okay, and now iterations, let's increase to 50, much blurrier I would say. Okay, and the last thing, we can see that the effect is slightly stretched horizontally, because that's the aspect ratio of our image. To achieve the same result regardless of the image size, we'll introduce our usual aspect ratio, which we'll obtain from the texture pixel size variable. I'll do it here. So vector 2 resolution is 1 divided by texture pixel size. Is nothing new for you if you've been watching my previous videos, of course. And float aspect ratio is resolution x divided by resolution y. Alright, and we'll recalculate the offset vector, which we have here. So instead of 1, we'll simply divide that by the aspect ratio. Wait. Yeah, it's definitely not stretched anymore. But it seems that this line is already too long, so I'll split it into 2. Let's take this part just after the rotation, and offset would be multiplied by this part. Alright, I think we've achieved a good result. And as I mentioned, there are really many options for setting the noise texture. So combined with the other parameters, it gives us an endless variety of ways to tailor this effect to the needs of our game. Thank you for watching. And if you manage to improve this algorithm, I'd be very happy to read about it in the comments. I hope that in the meantime, we'll also make progress on the development of our new game, and I'll be able to talk about the techniques we've used to create it in one of the next videos. For now, take care, and I'll see you next time.